All right, so we have a couple of people, at least one person, two people now signing on. So welcome, hello. I hope everybody had a great week. We're gonna give it another minute or so to let everybody join. And just a reminder, as always, these slides and the code and everything that you need is posted on Canvas. And so feel free to have that downloaded and follow along. There's a little bit less code today, but it's quite a bit more complicated. So we'll be covering less ground, but in more detail. Okay, so now I see several more people joining. Welcome, everyone. All right, so we'll get started. So this week, what we are going to be talking about are interactive user interfaces. So we're going to be moving away from the math and the modeling, and we're going to talk more about how to communicate your results. So interactive user interfaces is that place where interactions happen between humans and machines. So some examples that you might think of when you think of interactive user interfaces would be some sort of website or dashboard that you're able to, as this photo sort of shows, click and drag on a sliding scale and it would actually update the plots in real time, for example. And so interactive UIs or user interfaces have a wide range of applications that they can be used for. And I should say that this is something that I'm doing more and more in my own life, in my own career. Um, there are a lot of sort of emerging uses for interactive UIs. So first of all, interactive UIs can be really helpful with exploratory data analysis and modeling. So UIs don't just have to be used to present your final results. They could actually be built ahead of time if you know exactly what kind of data you're going to be getting. And you could use the UIs to be able to visualize your data and explore it. Or more importantly, help other people do that if they don't have the coding skills that you all now have. Of course, you can also wait until your results are done and communicate those results to stakeholders in an interactive way. This really encourages lateral communication. It transforms different types of knowledge to each other. So for example, you might have a really good understanding of the math that's happening behind the model. And maybe somebody else in the room has a really good understanding of domain knowledge. So maybe has more insight into why it's happening. But if they don't have the opportunity to sort of explore your models, they might not ever realize that they could actually contribute something really important. Interactive UIs should always be user-friendly. So you want to keep your end user in mind. Make sure that your labels are very clear, that any instructions that you're giving about how to use this UI are very clear. And UIs can also be used to boost customer engagement or to increase the exposure of your company or your research or your project. And in some cases, you can use interactive UIs to collect data from users. That brings with it a host of challenges, but one of the first UIs that I ever really built that was being used was in a research team where I was working with recreational fishermen and I was tagging fish and I wanted them to let me know when they caught these tagged fish. So I built them an interactive UI. They could go on their phone, and when they caught these fish, they could immediately enter the data and it would be put into my database to be used for my research. So you can actually collect data from users as well. So there are many different ways that you can build an interactive UI. Because this course we've really focused on R, we are going to look at the tools that R has for building these tools. So there's a package called Shiny. It's sometimes referred to as R Shiny. And what it allows you to do is to build an app entirely within the R framework. So these apps end up being compiled as HTML documents. So if you have any experience with HTML or maybe building apps using other programming languages or other systems, um, you'll be happy to know that these HTML documents that are compiled can be styled using CSS. They can be enhanced with JavaScript. You can do a lot of far more complicated things with them, building dashboards with drag and drop functionality. You can use asynchronous programming to increase scalability. You can incorporate Google Analytics. You can sanitize your error messages. You can do almost anything you can think of through Shiny. But the most important part for the rest of us, for those of us who don't use a lot of JavaScript or CSS or HTML, for those of us who don't know what asynchronous programming is, that's all okay. Because the key point with R Shiny is that you don't need to use any of these extra pieces. You can stay entirely within the R framework and the R language that you already know and build something that is going to work for you and it's going to look good. So Shiny apps, there are probably a dozen different ways you can put them together and structure them. Um, what we're going to be doing today, in my mind, is the simplest way to do it. It's the way that I still do all of my apps. But depending on the purpose and the scalability that you want your app to have, maybe you would want to try a different structure. However, every Shiny app is essentially made up of two components. So the first component defines the user interface. So that is, what does the user see? And the second component defines the server function. In other words, what does the app actually do behind the scenes? So first, let's talk a little bit about the user interface. Again, this is what the users are actually seeing when they open up the app. And this is going to define the layout of the app and what elements appear in each portion of the layout. So the UI layout information is stored in an object that we call UI. So this is coming back to using R and creating objects like we have been doing so far in this course. So to define your user interface layout, you create an object, you call it UI, and then inside that object is where you specify all of the layout, all of the elements, and what exactly the user should see. So there are many different ways of specifying layout within this UI object. In my mind, the simplest and sort of most flexible starting point is this function called fluid page. Fluid page allows you to specify the layout of your interface in a number of different ways. So for example, you can use fluid page to specify that you want an app in panel mode, where the app has a side panel and a main panel. You could define a grid mode instead, where essentially you take the entire real estate of the screen and you split it up into rows and columns, and then you can put something different in each of those squares. You can also have tab mode, so you can navigate across multiple tabs. You actually have several different interfaces that people can step through. And you can mix any of these methods. So in this example, we have tab mode, but we also have a main panel that maybe stays the same. So you can be very flexible with your UI layout. These are just some examples of some of the layouts that are out there. And as I said, because all of this is compatible with things like JavaScript and CSS, if you have something in mind that you don't see here and you aren't able to find, you can build it from scratch on your own. It is possible to do that. So we have the layout and we have these different spaces where we're going to be putting information. And to define what information we're putting in each of these spaces, we have to define elements. Okay, so there are many different elements that can be used. What's really nice about R Shiny is that there are a huge number of predefined elements, sometimes called widgets, that are already available for you to pick and choose and use as you want to. So for example, The most simple type of element would just be a static element, so maybe a block of text or a photo, something that isn't interactive in any way, maybe just a set of instructions or a note about where the data comes from, for example. They can also, these elements can also be interactive. So in the interactive sense, we are asking for users to give us some information, user-defined input, and then you use that input to do different things. So we're going to see that when we start looking at the code. And so some of the predefined interactive widgets that are out there include things like free text, where your user can type in whatever they want. They could have something like a series of checkboxes that they can toggle on and off, and so on. So again, we're going to look at a few of those when we get to the code. And then finally, we can have elements in the UI that are reactive. So these things like figures and maybe data tables, figures are kind of the most common one. So figures would change or react to changes in the input. So for example, if you had an app where a user had a checkbox that they could either check yes or no, and depending on whether they checked yes or no, something in the figure would change, then that would mean that that checkbox is the interactive piece, and the reactive piece is the figure. The figure would react to changes in whether or not the user is choosing yes or no. Really interestingly, and we are not going to get this deep into it today, but you can also make reactive figures interactive. So for example, you could have a user that checks, say they select a certain number of countries, and there's a figure, and the figure reacts to the number of countries that they have selected, and they plot all the data from those countries. That figure could then be made to be interactive so that users could move their mouse over to the figure and actually click on points and have different things happen. So it's all fairly flexible. As you can imagine, the code complexity is certainly going to increase this week. So we're not going to go through a lot of code, but it's going to be very dense. So that's the first component. That's a user interface. So we create a UI object, and in that object, we put all of this information. What do we want it to look like? What do we want to go where? What pieces do we want to be interactive? What pieces do we want to be reactive, and so on. And then the second component is the server function. So we are going to build a specialized function called server, and that function will define how elements react to user-defined input or to changes in user-defined input, and how reactive elements are rendered or drawn to the interface. So for example, if somebody checks off Canada on the list of countries, the server function will say, okay, what do we do with that information? Where does that go? And how does that influence reactive elements? And then how are those reactive elements, say a figure or a table, how are they actually drawn to the UI so that the user can see them? So the server function is really all about reactivity. Anything in your user interface that has any kind of reactivity, so a figure reacting to a different selection, for example, anything with reactivity has to be defined in the server function. The server function must explain what that reactive object will actually do. So there are several types of reactive objects or reactive elements in Shiny apps. These are the three that we'll really focus on. There's a source, a conductor, and an endpoint. So the simplest path is from source over to endpoint. So if you have an element in the UI that is defined as being reactive, so you have a figure and the figure is going to react to something, it takes something from the source, and at the end of the day, it draws that figure. Now, sometimes we have a step in between, and we're going to see that at the very end of today. And we have this conductor where instead of taking sort of this raw information from the source and creating a figure out of it, sometimes there's some intermediate steps that have to happen. So the biggest thing is that anytime when we start looking at the code, anytime that you see a function in the UI that looks something like this. So UI output, there's other ones, there's I think plot output, table output, there's a few others. But anything that looks like this that ends with output, that is a sign that that element needs to have its reactivity defined and specified in the server function. So if any of you have experience sort of building apps or doing anything with interactive UIs, you may remember or you may know that traditional programming with interactive UIs require a ton of work behind the scenes. Setting up event handling, so what happens if somebody clicks this button? What are all the different pieces doing? And what's really nice is that Shiny does all of this behind the scenes for you with these built-in widgets, so that you don't have to worry about suddenly needing to write event handling protocols, for example. I will often not go into too much detail with these slides, but I wanted to have them here for anyone who might be interested. There are lots of different ways to deploy these apps, so to put them out there and have people be able to see them. You can deploy them where the user has to run something locally. So this is most common if you are sort of doing like an internal app. It's really only for your research team, for example. It's not open to the public. Or you can deploy them as web apps that anybody can see. And depending on what exactly you need and the scalability and what you're hoping to get out of this app, there are lots of different ways of deploying it with different levels of sort of flexibility and scalability. And then finally, I just want to note, again, this is really just for your own reference when you're going through these slides. You are able to set up persistent data storage with these web apps. So for example, when I said that I was getting recreational fishermen to go onto my app and enter data, and that data was put into a database, that database was hosted on Dropbox. And so I was able to set up my app in a way that I could use an authenticator to connect it to my Dropbox, and then anybody who is adding data, it had a system to go through to actually be put into my database. So there's lots of different types here. There's a little bit of information. There's a really good article here about persistent data storage around Shiny apps. Okay, I'm just going to take a look at the chat before we switch over to code. What are the tools that we have to develop UI, and can we embed other languages with R? Yeah, so there's lots of different tools. I primarily or exclusively use Shiny. Even within Shiny, there's a few different flavors. So there's Flex dashboards, Shiny dashboards, regular Shiny, which we'll be learning today. In the Python world, there is a similar sort of package called Dash. I haven't used it, so I don't know what it's like. And then there are the more classic things like Tableau and others. So some of those you can embed other languages into. Some of them I would imagine you can't. With R, if you're using plain R Shiny, then you can use R and you can embed CSS, HTML, and JavaScript. If you are creating it in tandem with Markdown files and you're using R Markdown files, then I believe you can also embed Python, SQL, and I think there's another one, Julia maybe. So there are lots of options for sort of piecing together different languages to make things exactly the way that you want it. And then the other question, what database was that? Oh, the phishing database. That was just a really simple like SQLite type of data set. So it was not overly complicated, but it was just files that were stored on Dropbox. And so I was able to link the Shiny app to that data and have everything connect and be organized very nicely. Okay, so I'm going to switch over to the code. So I'm going to stop sharing for a moment. Now today, the way that the code is going to work, there's going to be other windows popping up with these different apps. And so rather than just sharing my RStudio screen, I have to share my entire screen. I'm pretty sure I have all my notifications turned off, but fingers crossed. Hopefully it won't be an issue. Okay, so this is the Module 10 code. This is available on Canvas if you want to follow along. And I want to preface all of this by pointing out that this code is way more complex than any code that we've seen so far. And so the number one thing that you should do when you're learning Shiny is not try to ever write it from scratch. Even now, I don't know how many Shiny apps and dashboards and such I've built. I would never try to write a Shiny app just from scratch, opening up a blank .r script and saying like, okay, let's start typing. It's very complicated. And so there's a lot of really good sort of outlines or examples online. And the best thing you can do is to copy paste that in and then figure out the pieces that you need to change, at least to start. And so, yeah, please don't feel too overwhelmed by this code. The biggest challenge that you're going to have with this is that the entire Shiny app is 2 lines of code, but they're 2 very, very large lines of code. And so you have to be really careful about brackets and commas because it's a whole bunch of functions nested inside of each other. So that's the trickiest part, because it's, the entire user interface is 1 line of code. It makes it really hard to troubleshoot because you can't test out just pieces of that line of code. You can only run the entire line of code. And if it says, there's an unexpected bracket, you now have to go through the entire line of code and figure out where that bracket is. So it is challenging. I weirdly kind of enjoy it. I love trying to troubleshoot code and counting brackets, but I don't think that's a normal thing to like. So we are going to start by importing the libraries that we need. So we're going to be using some dplyr and some ggplot2, and then we're going to be using this Shiny library as well. Okay, so remember, if you run this and it says something like, error, there is no library called Shiny, just remember that you'd have to use install packages, and you'd have to run that first so that you install the package before you try to load it. Okay, so again, Shiny apps are composed of 2 pieces, an object called UI and a function called server. So what we're going to do is I'm going to start by running the entire app, showing you what the app actually looks like, and then we'll go back to the code and see how it all fits together. So there's this piece of code called basic app. This piece of code that I'm highlighting, and we will go back and look at this in more detail. This defines the UI object, the user interface, and the server function is defined by this line of code, and then we can run the app, and we're going to take a look at that before we look too deeply into the code. So this app is very, very simple. We are not at this point necessarily making beautiful looking apps. First, we're kind of figuring out these interfaces, figuring out these servers, and making this work for us. So what this app does is we ask the user to provide input. So choose a number. They can choose a number from 1 to 5. So this is the interactive piece. And then you can see that when you choose a number, the point on this plot moves to an x position of that number. So when you choose 4, the point is x equals 4. When you choose 2, the point is x equals 2. And so this figure is there we go. So this figure is the reactive piece. This figure is reacting to changes in the interactive piece where the user changes the input. Okay. The other thing we can see about this app is that we have that sidebar panel layout. So we have a sidebar panel. If we had more options, this would go all the way down to the bottom. And then we have the main panel. And the main panel is where we've put our reactive object. And the sidebar panel in this instance is where we've put our interactive object. Okay, so let's take a closer look at the code and see how this actually comes to be. Oh, Steve says, are we supposed to see the app now? Yes. Should have the entire screen being shared. Let me try switching. I'll turn it off and turn it back on. Is that better? Okay, perfect. All right, so just to reiterate, so we can make sure that we're all seeing this. So this is what the app looks like. Again, it's not very pretty. This is the sidebar panel that, if we had lots of different choices, would extend all the way to the bottom, this kind of dark gray area. We have the main panel. And in the main panel, we have the reactive figure. And that figure reacts to changes in the interactive piece where the user provides input. So the user chooses a number, and the point is plotted at that value of x. Okay, so we're going to go back and we're going to take a look at how the code actually builds this. Okay, so first of all, the user interface, UI. So remember, we're starting by creating an object called UI. So this is something we've done lots of different times. And as I showed you in the slides, one of the simplest ways to get started on defining the user interface is the function called fluid page. Okay, so we're going to say the thing that we want in the UI is going to be built with this fluid page function. So the thing that I want to do, and I'm going to actually do this for you just so you can see what's happening here. I'm going to copy paste all of that. And I just want to quickly show you how it is actually one very long line of code. If I got rid of all the comments and all of the extra spaces, you can see that this is just one very large piece of code with a whole lot of brackets and commas and different arguments. So we want to dissect this a little bit just to sort of see what's happening. So fluid page is taking two arguments. Fluid page, the first argument is going to be defined by this sidebar layout. Actually, sorry, fluid page is taking one argument. The next one will take two. So fluid page is going to take information from this function sidebar layout. Now, sidebar layout, in turn, is taking two arguments. One of them is created by the select input, or sorry, the sidebar panel, oh my gosh, sidebar panel function. And the second one is the main panel function. Okay, so you can see how already this gets very, very nested. Fluid page, we say, all right, the way that we want our page to be set up, we want the sidebar layout. Inside that sidebar layout, we have to define what is our sidebar panel and what is our main panel. And then within those, we're going to tell our exactly, what we want there. So keep that in mind, that that's sort of how everything's built. It's a whole bunch of functions inside of each other. So it's a little bit easier to sort of lay things out like this. It's okay to have these extra line breaks after open brackets and after commas. So we say fluid page, this is the information that we're giving it. It's all part of the sidebar layout. Here's the information that we're giving our sidebar layout. And we're saying on the sidebar panel, the thing that we want is this widget called select input. Okay, so that's where we had been asking our user to choose a number between 1 and 5. So anytime you're asking users to provide input, you have to give that input some identifier, some name. And so, for example, here, let's call it my number. Okay, so when they choose a number, that number gets called my number. Okay, so the input ID is my number. The second argument that select input needs is the label. So what does the user actually see? What are the instructions? Here we say choose a number is our label. And then the third is what are the choices that the user is able to choose from? And so from here, 1:5, if we even just run this down in the console as a reminder, 1:5 will print all the numbers from 1 to 5, all the integers. Okay, so this says, okay, users choose a number from 1 to 5, and when they do, that value that they've chosen is going to be stored in something called my number. So that defines the sidebar panel. And then the main panel, we have said in the main panel is where we want our reactive figure. So because it's reactive, we can't tell the UI what it's supposed to look like because it's going to change based on what number is selected. And so we have to define that reactivity once we get to the server function. So for now, what we say is in the main panel, we are going to have some output. So remember from the slides, anytime in the UI you see output, it means that's something you have to deal with later on in the server. And you're going to say, I'm going to plot a piece of output, and the name of the piece of output that I would like to plot is going to be called my figure. Okay, so all of this together defines our user interface. And then we go down here to the server function. And this is how we set up the server function. We say we are creating a new function called server. That function is going to require input, and it's going to give us output. Here, the input that it's going to take is called my number. And the output that it's going to give us is called my figure. Okay, so because often you'll ask for many pieces of input and maybe produce many pieces of output, these actually get stored as a list. Okay, so for example, all of the different pieces of input that a user will give you. Say that you ask them to choose a number from 1 to 5, call that my number, and you also ask them to choose a letter from A to W, call that my letter. That means that there's an object called input. The first component, the first piece of that object is called my number and contains the number that they chose. And then the second piece or the second item on that list is called my letter, and it would be whatever letter they chose. So here we're saying that we are going to create something called output, and there's only one thing in it, but we still have to name it. The one thing in our output is called my figure. And what we want my figure to look like is we want it to render or draw a plot. Okay, so we have render plot. And this is the plot that we would like for it to render. Render just means draw. Okay, so this is using the old plot function. We're not using ggplot right now. We will in the next example. But we are saying here that we just want a regular, simple scatter plot where the x value is defined as whatever my number is from the input. We'll say we'll make the y value always equal to 1, and we'll say that the limits of this x-axis should go from 0 to 6. And that's just so as we're choosing numbers and the input my number changes, we can actually see how it moves around on the screen. Okay, so these lines of code, it's, again, one very long line of code, defines our server function and says, what do we do with the input and what output would we like to produce? So remember, anytime up in the UI you see something that talks about output, you have to define that specific piece of output down in the server. So here, the output is going to be called my figure. And so in the server, you have to define what is the output called my figure. And then to run the app, we use the Shiny app function, and we give it 2 arguments. The first argument is UI, and the second argument is server. And that will run both of those pieces of code together to actually produce that app that we saw. So I'll bring that up again. Okay, and then I'll go to the chat. And I recognize that this is very complicated and it's going to take a lot of practice. But once you're able to build even very simple user interfaces, you suddenly open a lot of doors, and it's a really powerful tool that people are really loving right now. So Francisca is asking, so our chosen number is stored in my number and the plot is stored in my figure, right? More or less, yes. So the chosen number is stored in a list called input with the name my number. So if you are asking for a whole bunch of different choices, then it'll be, input my number is the number that they chose. Input my letter might be the letter that they chose. Input my country might be the country that they chose, and so on. But essentially, yes. So instead of saying, for example, that this render plot is called my figure, you have to specify that that is inside of this bigger output object. And Josh is asking, will R throw an error if you forget to define an output? That's a great question. Troubleshooting Shiny is very unfortunate. It's not intuitive. So up to this point, we've had fairly simple troubleshooting in R. Troubleshooting Shiny is a lot trickier. So for example, let's say that we forgot to call this output my figure. I don't know what will happen here, but we're gonna see what kind of error we might get. When we try to run the app, let's see what it does. Yeah, it doesn't give an error. It just says that there's nothing that we can do. So it can't find the piece of output that it's supposed to have, and it just doesn't show anything. Other times you will get errors printed in the app itself. So there'll be red letters saying, error, whatever has happened. And often they are very, very difficult to interpret, and sometimes are next to meaningless. So most of the time, what matters is that you're probably missing commas or brackets. That's like the biggest, most common problem that you run into when you're trying to troubleshoot Shiny. So I'm just going to return this. And Francisco is saying, I tried to modify X in render plot by multiplying input number by 5. Nothing happened. So doing this, for example, let's see, whoops. See, so what happened here, this error that I got is I accidentally just tried to only run this line of code. And this line of code by itself is like, I don't know what this means. You have to make sure that this whole piece is actually run. So let's see what happens if we do times 5. Yeah, here, error non-numeric argument to binary operator. Let's see, what could that mean? Input my number. I'm not sure if I've clicked something else or not. No stack trace available, so that's not helpful. Okay, I believe it is difficult to do something. It sounds silly, but I think it's more difficult to do something simple like that, saying, oh, I just want to multiply this by 5. If you want to modify this before using it, there's an extra step that you have to do in your server function. And we are going to see that in the next example, where we build a more complicated app. So you will see, what is that extra step that you need to do. I was hoping, like you, that if we just said times 5, that would be enough, but it's not. Okay, so that is sort of the first Shiny app. Now let's step it up and actually make an app that's somewhat useful, although much more complicated. So we are going to be using the income data set, just like we have been before for a few of these. And just as a reminder, if we want to quickly look at the head of our income data set, we have all this information about, different demographics and professional data, and then ultimately what their income is, capital gain, capital loss, hours per week, etc. So once again, I'm going to run this entire app we'll take a look at it, and then we'll kind of go back and dissect the code and see how this all fits together. So just as a note, this is the line of code that creates our interactive, our user interface. So all of this. And then our server function is going to be pretty huge because there's a lot of things we need to do. So this is all one very large line of code. And that's our server function. And when we run this, what we'll see is we have now a slightly more useful app. So here, what users are able to do is to click here and select different countries. I'm just going to grab a few of them. Obviously, this data hasn't totally been cleaned because there's a country just called South. That's something that you'd want to take care of ahead of time. Oh, maybe I won't do United States because there's a little bit too much data there. What other ones? What about Canada? No, all right, well, there's a whole bunch of different countries. You can see that users can select multiple countries from that drop-down menu. And what this is plotting is we are looking at capital gains by age, and we have this straight line that is automatically drawn through it, and it's a linear model, smoother. So it's essentially a way that you can ask ggplot to just draw a linear model. It doesn't give you any information about, our squared values or loss functions or residuals. It can't be used to make predictions. It's just draw the line that would represent a linear model here. And then these gray areas are some sort of confidence intervals. You can see that they're pretty terrible. But this is something that could be really helpful when you're just trying to take, a first glance at your data. And so right now we have a different line for red and blue. And here red is female, blue is male. But maybe we'd say, well, instead of coloring the points based on gender, what if we colored the points based on marital status? And so now the red points are married people and the blue points are people who are not married. And then the other thing we can do is say, well, we don't actually want to use the entire age range of the data. We really just want to look at, 25 to 45-year-olds. Okay, so you can see that reduces the points that are shown, and the models actually, or the model line actually changes. As you can see how it is adjusted as we adjust the age. Okay, so again, not a very pretty app, but you can start to see some of the types of utility that you might be able to do in these kind of apps. So I'll exit. Before we start looking at that, I'll take a peek at the chat. Yes, Steve says you'd have to increase the xlim on that previous example. Yeah, you would, but that wouldn't correct the error that was coming up. That would just, if that error wasn't happening and the plot was rendering as expected, then yes, you'd have to increase the xlim to actually see the point once it got past 6. Okay, so let's take a closer look at the code that builds this app. So first we have our user interface. Okay, and so here you can see that we have actually added a new argument to Fluid Page. Our first app did not have a title. This one we said we'd actually like to give this app a title. We do that using this title panel function, and it becomes the first argument of Fluid Page. So if we kind of write things out like we did before, we now have Fluid Page where the first argument is title panel and the second argument is sidebar layout. And I'll say, for me, this is one that I never remember what the function is, where it belongs, or how to use it. This is something that I Google every single time I make an app. I go, right, how do I put a title on it? Where does that go? Okay, it goes in Fluid Page as the first argument. And so it's okay to sort of be like, well, how would you ever know that title panel goes there? Well, you don't. You Google it, you look at code from other apps. I'll show you a resource at the end that's really, really helpful for doing all of this stuff. Now, I don't know of anybody who can sit down and write Shiny apps from beginning to end without doing copy pasting and looking up references. Okay, so in our title panel, we give it a title. So you may have noticed the title of that app was Module 10, Shiny App Demo. And then in the sidebar layout this time, things will be a little bit more complicated. In sidebar layout, we are still going to have our sidebar panel, and we're still going to have our main panel. But in our sidebar panel here, instead of doing one piece, remember last time the one thing that we gave it was that we wanted people to be able to choose the numbers 1 to 5. Here we're actually giving it 3 interactive pieces. And so each of these little groups of 3 dots represents one of the interactive pieces that we'll have to put into it. And then the main panel will still just have a single reactive figure. Okay, so the first interactive piece that we want this app to have is that we want people to be able to select different countries. Okay, so this is the line of code that we'll use to do that. So this line of code would essentially be these first 3 dots. And every time we ask for input, remember we have to give it some sort of name. And so here we're going to say that when people choose countries, we're going to store that information as input subset country. The label that we're going to give this interactive piece, so the set of instructions, tells the users select countries. And then the choices that they can choose from, we don't want to type them all out. We could, right? We could say, all right, the choices that you have to choose from are going to be Canada, England, so and on, and type them all out. But of course, that's going to lead to a lot of opportunities for typos. It's going to take a long time. It's going to be annoying. And so instead, we could say, just use all of the unique values that are in that country column of the income data. Remember that up here, we read in. Okay, so we have our regular income data. We have that column called countries that you can see your country. And we're saying take every unique value that's found in that country column, and those are going to be the choices that people can choose from. And then the other thing that we noticed that's a little bit different about this interactive piece compared to the last is that in the last instance, people could only choose one number, right? So they had the drop-down menu and they had to select one value from 1 to 5. Here, we want people to be able to select multiple countries if they want. And so we add this extra argument called multiple equals true, right? So by default, this argument is multiple equals false, but we're going to say multiple equals true. People are allowed to choose more than one. And what that will do is when we, maybe I'll run this, run this app again so we can take a closer look at that. Instead of having, this drop-down menu where you can choose one or the other, it has a blank value. And when you click on that, there are all the different values and you can click on whatever you want. It also allows you to do cool things like saying, show me anything that starts with, there we go. Anything that has an N in it, for example, and be like, oh, here are the ones that you might be looking for. You could start to type in a country and it would bring up, okay, well, this is the only thing that fits, and you could click on that. So having that multiple option gives you more flexibility and more power. Okay, so that is what this line of code does, or what this piece of code does. Okay, so the second interactive piece, which will go here in the sidebar panel argument series, is do you want the color of the points to be based on gender or marital status? Okay, so we're going to say that when that input is selected, we're going to call it input set color. The label that users will see is color points by, and then they can choose. And then we're doing one other kind of different thing here. So what we're eventually going to do is we want to say that they take they choose the column name that later on ggplot will use to base the color of the points on. The problem is that the column names are not super pretty. Okay, so gender isn't too bad. This is the actual column name. It's gender with a lower g, lowercase g. That's not so bad. But the column that has to do with marital status is called grouped underscore marital. And so if you were to give this app to somebody and it said color points by, and their options were gender or grouped underscore marital, they might look at you and say, I have no idea what grouped underscore marital means, right? So you always want to make sure that's user-friendly and clear. And so what you can do is in your choices, you can give them sort of pseudonyms. You can say, okay, if they choose gender with a capital G, they're actually referring to the gender column. If they choose marital status, capital M, capital S, no space, they're actually referring to the grouped marital column. So it just makes it a little bit easier for people to actually understand what the choice is that they're making. And then finally, the third interactive piece, which fits here in the sidebar panel series of arguments, is going to be what is the minimum and maximum age that you want to include in the figures. Okay, so these first two, we used a widget called select input. But this third piece, we're using a different type of widget. We're using one called a slider input because we don't want people to select values. We want people to have access to that slider that they can actually move back and forth, slide back and forth to choose the maximum and minimum ages. So the input that we're going to get from them, we're going to call subset age. The instructions or the label that they see is age range. And then because we have a slider input, we have to give it slightly different information. We have to tell it what is the minimum value that they can select and what is the maximum value that they can select. So the minimum value, we could go through our income data. We could figure out what the minimum age is. We could make it up. We could say the minimum they can choose is 0, but we don't have any data from 3-year-olds. So it doesn't really make sense to give them the option of saying, show me all the data from 3-year-olds. So instead we say, make the minimum whatever the minimum age is in the actual data, make the maximum whatever the actual age is in the income data. And then this piece of information right here, this is something that you don't have to do, but I really like doing it. So what this is going to do, I'm going to run the app again so we can see. When we look at the slider, you notice that this is kind of the default. This is how it opens up. You see that the slider goes from 17 to 90. So our minimum age was 17, our maximum age was 90. And what we could do, I'm going to actually try to show you the code and the app at the same time. No, I don't think that's going to work. Okay, well, what we could do is we could have these starting points. By default, it's going to say, show me data from 25 to 75. We could have these all the way at the end, right? So we could start like this and say the age range that we're looking at is from 17 to 90. But surprisingly, or maybe not surprisingly, it is very common when people open up some sort of interactive app like this, they don't realize that they can actually move these buttons, right? Because if they're all the way to the end, they might think, oh, it's just telling me what the age range of the data is, which isn't the case. So I like to start by having these buttons just a little bit in from the absolute extremes so that people can look at this and say, oh, look, I can actually move these. It's a little bit clearer for users. So I'm just going to wrap this up and then I'm going to go back to the questions. I see there's a few. And so I have these started when you first open up the app, it goes from, I believe, 25 to 75 is like the default starting points for these buttons. And the way that I define that is by adding this extra argument in the slider input that says value, and I give it the vector of the two values of where I want the original starting and ending point to be. And so that is all about communication and making it user-friendly and making sure that people know that they're able to move that slider around. Okay, let me look at the chat. Seems like there's a lot going on. Okay. Francisco, what does listing on this mean? What does this piece down here? And yeah, Steve, you're correct. This is just the specific kind of local address of where this app is. So I am building this locally. This is just on my computer, but you can do this where you deploy it to a website, for example, and things like that. So this is saying that it is launching that app on my own computer. Okay, and Ali is asking, how does the second select input know that the parameters gender and group marital come from income? Yes, you're right. It doesn't know that. At this point, all that it knows is that if somebody chooses gender with a capital G, this is what they actually mean, gender with a lowercase g. And if somebody chooses marital status written out, what they actually mean is this grouped marital. And so right now it's not linked to our income data at all. We know that those are columns, but right now R would have no idea. It would just say, okay, well, if the person chooses marital status, what they really meant to choose was group marital. Later on in the server function, we're going to use that information to say, find these columns that are named the things that people selected or the pseudonyms of what was selected, and then go find that information. So right now, this select input is not linked to the income data in any way, except that we know that these are the column names that eventually we're going to be looking for. Whereas here, for example, or let's say here, for example, we are actually saying we want the minimum value in the slider input to come from the income data. Francisco is asking, the reason to add value C2575 is aesthetic and to set the initial setting of the slider. The min and max is set by the code right before that. Yeah, exactly. So this is the minimum possible value on the slider. This is the maximum possible value on the slider. And these are the starting values. When somebody first opens up the app, what are the default selections that have been made? Okay, and I don't think there's any questions on the Q&A board. Okay, so that is, or those are our 3 interactive pieces that we put into the sidebar panel. In the main panel, what we're going to say is we want to have a reactive figure that is output and rendered or drawn into this main panel. So in the main panel, we want to have a piece of output. It's a plot output. So we use a plot output function. And just like in the first example, we are going to call this my figure. So we know that in the server function, at some point, we need to make sure that we create something that goes into output $ my figure, because that's what this function is going to be looking for at the end of the day. Okay, so that is our UI object, this whole piece of code. And now we're going to get into our server function. And as you can imagine, the server function here is going to be much more complicated than last time. So we have to think about the different things that we need to happen before we even try to draw our plot. So we are asking people to select specific countries and select and specific age ranges of the data that they actually want to see. So that means that every time a user changes that input, they select a new country, they increase the maximum age range that they want to look at. Every time they change the input, the data set has to get subsetted in a different way. So the first thing we want the server to do is to take the information that has been given to it by the input and subset the income data to only contain the data that the user has specified that they actually want to see. So we're going to look at this in pieces as well. Okay, so for now, let's ignore this whole piece and let's just focus on the familiar dplyr code that we see here. So the first thing we want to do is we say we want to take the income. One thing that we realized from exploratory data analysis is that there's a whole bunch of capital gain that is like 100,000 and it really skews everything. And so for the purpose of this, we're going to say, let's actually only look at capital gain between 1 and 5,000. So that's the first filter we can put in. In filter, you can use a couple different syntaxes. We have been using a slightly different syntax, so I'm going to change that so it's more familiar to what we've been doing. So we are applying a filter that says only keep records with capital gain between 1 and 50,000. The second thing, only include the selected countries, right? So we are only keeping countries that are found in our input subset country. And that input subset country is defined here. Okay, this is where our input $ subset country comes from. These are all the countries that were selected. And we're saying from the income data set, filter it so that we're only keeping records from those countries. And then the third filter we want to apply is that we only want to include records of people that are of ages between the minimum age and the maximum age that people have selected. So our user will use the slider to create something called input subset age. However, it's actually going to give us back two pieces of information. The first piece of information that input subset age will hold is the minimum, and the second is the maximum. So here we're saying only keep records where the age is between the first value of subset age, which is the minimum, and the second value of subset age, which is the maximum. Okay, so this piece of code will subset our data so that we only have the data that the users are actually interested in seeing. And then the last thing we're going to do here, this is something that I think we did in logistic regression, but for whatever reason, the data set that we're using doesn't have this column. We have to create that grouped marital column. So we're saying if this is something we've done in logistic regression, we're saying create a column called group marital. If marital status is divorced, never married, or widowed, change it to not married. Otherwise, change it to married. Okay, so that's going to create that column that we want people to be able to access. So this piece of code that we've looked at, we take the income, we filter it, we mutate it to create a column. That's something that we should be fairly familiar with now. We should be able to recognize it. The difference is that we have these inputs, input subset country, input subset age, for example, because this is actually going to be reacting to the user input. So to make this reactive, we are going to wrap all of this information in a function called reactive. So there's an extra close bracket at the very end of this line that closes that function. And we're going to say every time we run a new function called create subset, we would like this reactive process to happen and for the data to be subset appropriately. Okay, so later on what we'll see is anytime you see something that now says create subset and a function with no arguments, this is what it's going to do. It's going to do this process. Okay, so that's how we're going to create our subset. This is the piece that I had said, sometimes you have these conductors, you have these in-between steps, and this is an example of that. This, it's not as simple as taking, the raw information from the user and dropping it into the plot. You actually have to use it to do something else first. And the something else in this case is that we want to subset our data. Okay, so now that we have our nicely subset data, it's reactive. That subset's going to change as soon as the user input changes. Now we have to say, how do we want this figure to be created? Okay, so just to add a piece here to make it a little simpler to look at to start, we know that it's going to be a piece of output called myFigure. And we know that what that output will do is it's going to render a plot. Okay, so that's where we're starting. Now, everything in here, in this render plot function, is going to describe what does the plot actually look like. Okay, and so for that, we're going to build a ggplot and essentially take the ggplot and fill this render plot in to say, when we go to render the plot, here's how we want to do it. So here is the ggplot code that we're using. So again, we've used lots of ggplot, so much of this will look really familiar, but there's going to be some new little pieces that we haven't seen yet. So usually when we do ggplot, remember the very first argument that we give ggplot is the name of the data set that we want to use. And so it'd be really tempting here to say, well, we want to use the income data set. But we don't actually want to use the income data set. We want to use that reactive subset process that we've set up above. And so instead, when we say, okay, ggplot, what data set do we want to work on? It's going to be whatever data set is produced by this create subset function. And that create subset function is going to subset based on the input. Okay, so that's the first kind of weird thing that we see, is that instead of giving it a data set, we give it instructions to create or modify the data set. Okay, so first we want to plot age and capital gain as a scatter plot, because remember on the x-axis we had age, on the y-axis we had capital gain. And here again, you're going to see that things are a little bit different. What you might expect to see here would be geom point AES, x equals age, y equals capital gain. Right? This is what we've worked with so far. This is what you would expect it to look like. The reason that it doesn't is because we need to add one more piece to it that says, what does the color of the points, what is the color of the points based on? And that information is what we gain from our, that color, deciding what column defines the color of the points is what we get from our input set color. And so you might even look at this and say, okay, well, that line of code should work. But what's really annoying is that this input set color is going to come back to you as a string. Okay, so let's say, for example, that the input that was selected was gender. You would expect that this is essentially how that line of code gets written. But instead, that input set color returns this. And so if we use a regular assistant, it can go to the data, it can find the column called age, it can find the column called capital gain, but it can't interpret this as the name of a column, right? It can only interpret that as the name of the column. As soon as you put quotes on it, our assistant doesn't know what to do. And so what we're doing instead is we're bringing in a new type of assistant. Instead of an assistant that recognizes only the names of columns without quotes, we have a special assistant called AES string that takes the same information, but will only recognize it if it is in quotes. So these two kind of do opposite things. And I will say that since building this module in the last 3 months, maybe, there's actually a totally new way of doing this. But I'm not confident enough about the ins and outs of it to necessarily guarantee that it's going to work. However, if you start going down this path and you start looking up things like AES string, you might see something possibly that looks like this. This very weird syntax. Sometimes you'll see that, other times you'll see this. It's kind of this new syntax that is coming out in R. Again, I haven't explored it enough to be very confident with it. And so instead of worrying about that, instead we're going to use the different type of assistant. And this assistant only recognizes column names if they are in quotes. So this ends up working because this returns gender in quotes. The next line of code is to draw that smoother, that line that represents a simple linear model of the data, and having those, big gray confidence limits around it. So this is a function we probably haven't seen yet, but we've seen lots of other geoms. We kind of have an idea of how geoms work. This one's called geom smooth. Again, we're going to use our special string assistant. We're going to say X is going to be the column that is called age, Y is capital gain, color is going to be color, and the one thing that we'll add outside of the assistant is that the method that we want our smoother to use is LM for linear model. So there's lots of different methods that can be used. Here, we're just sticking with a simple linear model. We're drawing a line. And again, remember that this linear model is not something that we can make predictions on. We can't get coefficients or our squared values. This is just drawing the line that would represent the model. Okay, and then the last few layers that we're adding to this plot, we should recognize. We are changing the limits of the x-axis so that they go from 15 to 95. That's because our youngest age is 17 and our oldest is, I think, 93. And it's just to kind of standardize that x limit so we can see things nicely. We'll use our theme BW to give our plot a nice clear background and black lines. This 18 is something that we may not have used before. We've probably used theme BW without any arguments. That's completely fine. But you can give theme BW an optional argument that has to do with the relative font size. So I think by default it's 12. So if you want your font to be a little bit bigger, you can add that into theme BW and not have to worry about it. And then we'll change our X and Y labels. Okay, so this piece of code that's highlighted describes the plot that's going to be made. That gets passed to render plot, like we see here. And that all gets stored as output my figure so that when the user interface looks for an output ID called my figure and tries to plot it in the main panel of our app, it knows what needs to go there. Okay, and so when we run all of that together and we run the Shiny App UI server, you see that this works. This brings up our app. So we're gonna stop there. I do want to give you a chance to ask questions, and I do really want to go over the assignment because the assignment this week is very different, and I really want to kind of demonstrate how it's going to be done. Okay. So I'm going to open a couple windows that will show you pieces of the assignment, but if you have questions, you can start typing them into the chat or the Q&A panel now, and then we can take a look at those. Okay, I don't see anything yet, so I'm going to start explaining the assignment, but I will answer questions before we go. So on the left is a screenshot of what your assignment looks like. Okay, I'll actually make it a little bit bigger so we can see. And with this comes a set of instructions, essentially saying, here's what we would like you to build. Here's what each of these interactive pieces should do. Here's what your app should look like. And then we're going to give you this piece of code. And so you can see that the main structure of the app is there. You have the UI object, you have the server function, and then mixed in there, we have a bunch of numbered blank spaces. So for example, this one and blank. And then what we're going to get you to do is to go through, fill in those blanks. And then on Canvas, we have a series of multiple choice questions. So for example, question 3, you can see here on the right, what is the name of the function used in blank number 1? Is it title panel, Shiny App, fluid column, or sidebar title? So you go back to your assignment, you say, let's look for blank number 1. Here it is. And if you've already figured it all out and you've managed to fill in all the blanks, then you would just say, okay, this is whichever of these, this is the one, this is the function that I used. If you're having trouble with it and you've said, I haven't been able to fill in the blanks, you can go back to the webinar. You can see the webinar here in the background. Find the line of code where we actually added the title and figure out what should go in that blank, right? So here it's title panel. So you would select this top one. That would give you credit for that question. And then you would go back to your code and you'd fill in the blank appropriately. Remember when you're filling in the blank to also delete the number, of course. And so that's how this assignment's going to work. Um, we, it's very possible that you go through and you just do the multiple choice and you figure out what it should look like and you don't actually build the app. That will work for you for this week, but next week, part of the assignment is going to be saying, take the app that you built and actually do something else with it. So it's in your own best interest if you don't just do the multiple choice part, if you also make sure that you're filling in the blanks as you go, and that you can make your app actually run. Okay, so I will stop sharing and I'll open up the chat. Yeah, Steve, fill in the blank title panel. Oh, that might be the only comment. As I said, Shiny is difficult. It's much more complex code than we've looked at. If you're feeling overwhelmed, that's normal and expected. I still feel overwhelmed when I look at Shiny apps, and I build them regularly for clients. So you're not alone. Maybe what we'll do, I'll give you another second or another minute or two to type in questions. Maybe I'll open up a more complete version of a Shiny app that I've built and sort of show you what that looks like. And then also, I think Kristen has a really good link to a website where she has a Shiny app that's deployed on a website that you can also kind of look and see, here's what you can do with this stuff. So give me one moment and I'm going to pull this up. Okay, and we'll share my screen. Again, I hope people are actively typing questions. Okay, so this is a dashboard that I've built for a wildlife group up in Nunavut. They wanted to be able to explore their data and really look at how things like caribou and polar bears are being harvested and how they're moving and how they're responding to climate change. So for example, in this case, this is my UI, all of this stuff, and then my server is defined here. So you can see it gets complicated quickly with lots of different pieces of output coming along. And I'll run that and hopefully not get any errors, but sometimes that happens. I think I'm in the right working directory though, so it should be okay. Yeah, and if you can see on the screen, there we go. So, this is another example of a dashboard that is built entirely in Shiny. There's a little bit of JavaScript, there's a little bit of CSS, but honestly, not very much. I don't use JavaScript or CSS, so it was very like, I want to do this one thing. Let me Google it, find the piece of code that I need, and figure out where to put it. And so here, you can interact with this map, for example, zoom in, see different points, different harvesting points. You can look at the raw data. You can say, I only want to look at data from, October through December. I only want to look at data that is from, people on a dog sled, for example. Okay, so that really limits the data in December, I guess. Maybe January to June dog sleds, that makes more sense. And then you can look at, the different communities, all the different species that were caught, the condition of those species, and then you can click on this button and export that data. So this is the kind of sort of final product that might actually be passed out to a client, and it's all built in Shiny, all built in R, like I said, except for little tiny bits of JavaScript and CSS. For example, one of the CSS things I had to do, so I had to go find this code, copy paste it, figure out where to put it in, learn a little bit of CSS. And the only thing that CSS does on this entire app is it lets me make this box purple and this box blue with those little symbols in it. So it was 100% aesthetic. I didn't need to do it. I just wanted to learn how. So this seemed like a good opportunity. Kristen, oh yeah, Kristen has just posted has posted a link to her website with her dashboard. So I will open that in 1 second. I'm just going to see these questions. Would you recommend creating marital status outside Shiny app? Yes, I would. I would recommend having all of the data in the best form it can be before you bring it into the Shiny app. So in this case, with the income data, we should have already had the filters for only looking at capital gains of under 50,000, should have already had the group marital column. That would make things much cleaner. So yeah, I would recommend doing as much as you can to the data outside of the Shiny app, so that in the Shiny app, the only thing you have to worry about writing up are those very specific filters that are defined by the user input. Do your files to build Shiny apps need to be in specific folders in your working directory? They just have to be in the same working directory. Okay, so if let me see, I'll share my screen. Let's see. Okay, I'm just gonna actually open. Okay, so this is the code to run that Shiny app. This is the data set that's used. So they're just in the same folder. So that's pretty well all you have to do. Steve does not have a lot of experience polar bear harvesting. That's fair. I don't either. We sometimes hear of them coming to communities near me, but I've certainly never seen one and never want to. Okay, I'm going to open up the website from Kristen. So this is a Shiny app that she has built and deployed on her website. 1 second to share my screen. Here we go. Kristen, do you want to talk about this? Sorry, I kind of just opened it.
Sure. So you have to scroll down. This is just mentioning up here that this was a survey that my friend Kate and I were writing a book, Mothers of Data Science. And so we had shared this survey across social channels to parents. So you could be male, female. We had a couple non-binary responses, but not enough to create charts. And of course, we wanted people to have children at home. And so there were a bunch of demographic questions, and then also questions around, did you receive parental leave pay? How long was your maternity leave? Do you wish it was longer? Have you ever declined a promotion or declined travel to a conference because of your children and, parental responsibilities? And so it was just really a super fun and interesting survey. And if you want to, so this one right here that Danielle is showing is, do you work remotely, and is it like full-time remote, part-time remote? And so this is of different parents that are in the data science field.
There's a really good example here too from, back in the slides when I said you can actually make your reactive things interactive. So you can have user input that produces a reactive figure, and then say, I also want to take that figure and make it interactive. This is a really good example. For example, these plots are reactive. They were produced based on the input given by the user, but they're also interactive because you can hover over them and things, for example, will pop up. It'll say, full-time in office, frequency 62, gender female. So you can actually get more information about the plots. And then you can also have all of these things.
It's actually really simple to do. It's just using Plotly. And so that Learn R and Shiny button is actually, I think it gives like 15% off to a R Shiny course that is like really comprehensive. And so I actually learned Shiny through those courses.
Yeah. Cool.
Yeah.
So yeah, we're hoping today that we've been able to kind of give you a, like so many modules here, crash course. Here's basically how it works. Here are the key things that you should know. And then really importantly, just know that this is possible in R. There's a lot of people I know who are in data science, who are in R, and they're like, I had no idea that you could do this in R. I didn't know R could build apps. And so yeah, we want to kind of really introduce you to that. And at least, similar to dplyr and ggplot, now if you see Shiny code, you'll recognize it as, I think this is Shiny code. I think this is actually building an app. I see a UI, I see a server. I kind of understand what's happening here behind the scenes. Yeah, so I don't see any other questions popping up. If you have other questions, if you want any pointers or clarifications around your assignments, I'll have office hours on Monday morning as always. And, please feel free to add things to the discussion board, submit tickets if you're having issues. And yeah, we are nearing the end of this course. So we really want to make sure that we're able to do everything we can to help you before it ends. Okay. So otherwise, we will see you next week. Good luck with your assignment. Good luck with everything. And thanks for joining us. Bye, everyone.